welcome to the 19th group exhibit of hydrogen and fuel cells at HANNOVER MESSE 2013. Please come and sit down, have a drink on us, and listen to our next discussion. We will be discussing expanding technology, the utilization in fuel cell and hydrogen generation. I will be speaking with Ken Burtt from Decksmet. He is the Vice President of Marketing and Sales. Please join him to enter the stage. Thank you. Hello, please take a seat. Can you tell me a little bit about Decksmet, how long you've been in business, where you're located, and a little bit of the technology and what you guys do?
Yeah, I'm from Dexmet Corporation. We're located in Wallingford, Connecticut in the United States, so we're just outside of New York City. We've been doing expanding metals and polymers since 1948. And we've kind of taken our technology and evolved it into more technically advanced materials for major industries like the fuel cell industry and for a host of other industries that, you know, everything from aerospace to medical to filtration. And we've kind of taken that expanding technology and we're just keep advancing that technology.
For those in the audience that don't know what expanding technology is, can you maybe give out a little more information about it and explain how the process works?
Yeah, expanding technology is essentially you take a solid material, whether it be a foil or a solid film polymer, and the process of expanding is it's a mechanical process that actually slits the material and stretches the material at the same time. So it's not really stretching, but what it does, it cuts the material and then pushes the material, so it's actually growing the material and creating an open area product.
So you said you're involved in different applications. What was the technology originally designed for, and what applications was it used for? Well,
we see expanded material on a daily basis. We just don't realize it's expanded material. If you've ever seen chain link fences or guards, or sometimes it's tables, it's actually produces a diamond-shaped material that you would find on the back of racks. Maybe it's staircases on stair treads, or maybe it's mezzanines. That's more the industrial type usage of the material. So there's the heavy grade, which is the industrials. There's a mid-grade, which is typically you would find on garbage cans and certain things that you find around your house, like ironing boards. And then there's the micro mesh technology, and that's really where our material is focused. So you're getting down to materials that are 25 micron thick, being able to put holes in it down to 25 microns, so it truly is a micro mesh technology.
So you've been involved in these other applications, and you've been in business for quite a long time. What was the reason for going into the fuel cell industry, and when did that shift occur, and why?
Well, we like to pride ourselves at the company. We've always tried to stay at the forefront of new technologies on where we can implement our materials into new technologies. Over the years, because people have needed so much of the open area products, and there wasn't a lot of availability of different technologies out there to be able to use. You know, alternatives are woven wire or perforated materials. So as we kind of involved in the company, we tried to go smaller and smaller on the hole size and thinner on the materials, and we became very good at designing equipment. And we design our own expanding equipment in-house to be able to push the technology envelope on the materials that we produce. And now that we've got those new technologies and that capability in-house, we go out and search for new applications. And the fuel cell industry is a wonderful application for us because they've been kind of boxed into having to use a woven technology or a perforated technology for so many years. And so we still, although the expanding technology has been out there for such a long time, we still have people that come by and say, I've never seen this technology before.
So how would you tell them, what were your reasons being for telling these individuals who haven't seen this technology, why should they be using it? What is it? You're saying stuff about the holes and the size of it and the thin layers. Can you go into a little more detail as to why some of these companies that are already using existing technologies would switch and use the expanded technology?
Yeah, expanded technology, the mechanical process of an expanding technology, it uses a die and it just basically cuts and slits the material. The geometric shape of that die is very consistent, so it's going to produce a very consistent product. It's made out of a solid piece of material, so it's going to have very good consistency across that material. So instead of using a woven wire product where you're constantly having to deal with wires, so if you want to cut a certain pattern, the material frays, and then you have to deal with the material fraying. Plus, two is because it's a woven technology, you have discontinuity between all the different strands. So if you're using it for some kind of electrical connection, you don't have very good conductivity or resistance across that area that you're using. So expanding technology, it doesn't have that woven process to it. So you're always using a homogeneous piece of material. So if you're looking, especially in fuel cell, where you're using multi-stacks of material and you want to have consistent conductivity from stack to stack to stack, the best material to use is an expanded material. Also, too, what's unique about the expansion process is that it produces or yields more material than you actually put into the process. So if you're using materials that are titaniums, niobiums, zirconiums, things that are very expensive materials, you can yield a lot more material than if you are perforating. So where perforating, you're taking a piece that may be 1 meter by 1 meter and knocking 50 to 80% of that material away as scrap to get an open area product. With the expansion process, if you put a 1 meter piece of material into it, the machine, you're producing, if you have a 50% open area, you're producing 1.5 meters of actually yielded material. So the cost benefits of using an expansion process outweighs all the other technologies that are out there.
So to summarize, for some that may have missed, this expansion technology helps maintain consistency, so allows for better stacking and increased flow, and also saves the material, so thus reducing the cost. Yeah, and that's really what it is. I mean, a lot of the technologies for the fuel cell industry, because they've used woven wire in the past, you know, have kind of dealt with those drawbacks from that particular material. And now we're trying to show them that there is a better material because, like we mentioned, the conductivity is a lot better, but the flow rates through the material, because of its geometric shape, the flow across the material is so much better than what you would get with a woven product, or if you're using a nickel mesh or a titanium foam or a nickel foam. Because that tortuous path, you build up huge pressures inside of your fuel cell. When using an expanded material, because of the flow rates, it allows the flow of the gases through a lot easier. It channels, if you're going to use it for a gas diffusion layer as a support material, it helps spread that flow across the diffusion layer better, so you get better conversion, essentially. So there's a lot of different uses within the fuel cell that can really benefit from an expanded product. In terms of engineers and designers, how do you work with them? Are these customizable? Do you work with the individual company to create a design and consistency specific to their requirements? Can you explain on how some of the individuals here could work with you? Yeah, what's unique about the expansion process is it's infinitely variable. And that's kind of, all the different materials that we manufacture, no two materials are alike. Everybody needs a material that has a different quality to it, and it's specific to whatever system that it's going into. We have a great technology group at Dexmet Corporation where the engineers, because of our technology background, can go in there and sit down with designers, sit down with engineers, and tailor make a product, whether it be a certain % open area that they would like to see, maybe it's a certain opening size, maybe it's conductivity. We can match all those criterias into a design and give them exactly what they need, instead of having them to deal with something that may be off the shelf, which may be inadequate for what they really need it for. So by working with the engineers and developing that specific material, essentially it gives them a performance advantage instead of having to use something that's off the shelf. Where do you distribute to, and where are these products, where is this technology manufactured?
Well, the technology is manufactured in Connecticut. All our machines are there in Connecticut, but we distribute and represent worldwide. Because of all of our different marketplaces, especially the aerospace industry, for some of you that may not be familiar with, expanding material in the aerospace industry, we're used as lightning strike protection on all the new carbon fiber aircraft that are coming out. So if you have a carbon fiber component on the aircraft, although the carbon fiber is conductive, they need some way to be able to dissipate that energy. So they use an expanded product over the whole surface of the aircraft to be able to do that. But because we were in the aerospace industries and working with so many European companies in the aerospace industry, we needed to become a worldwide supplier of materials. And one of the reasons why we are here is because the whole hydrogen and fuel generation process and the industry, and it's growing in Europe, just like it's growing in the United States. And we felt that we needed to be in these marketplaces, and we needed to be in front of engineers and designers to let them know that there is an alternative product out there for them to use.
Are there any questions in the audience at all? Anyone? Do you have any samples of these materials at your booth?
We do, and we really encourage people to stop by because we have a number of different materials. And I think if they'll see it, they'll understand, wow, this really is a unique material. Because a lot of people are used to seeing a woven mesh product. And if you can come by and see what an expanded micro mesh product is, they'll be very surprised on the ranges that we can do, on how thin we can get the material, and how small we can get the hole sizes, and what we can do with very strong and tough materials like titanium and stainless steels, and show you what our capabilities are.
So you said that you've been here before and you want to come to the show and enter some new markets. Can you go into a little more detail of the new markets and the avenues you're looking at exploring, and where the company is going?
Yeah, I mean, we're always looking for new technology that's coming out. We don't develop the technology. We like to see if we can implement our products into the technology. Where we see our company going is, obviously here in the fuel cells, and next year you guys are going to have the battery show here. We've been instrumental in a number of different battery technologies. We're typically used as anode or cathode materials in primary and secondary batteries. So we do a lot of development work with companies that are developing grid storage type batteries. So sort of large scale storage type batteries, whether they be zinc air or some type of other chemistry. And so we see that technology being designed and developed pretty much in same pace as the hydrogen technology as well, because they have to kind of go hand in hand. And we see the wind power is here, and that's a huge new technology for us too, because when the windmills, as blades get larger and larger, as they go over 45 meters, the technology that they currently use, which is a fiberglass technology, becomes too heavy. And so they start having to use carbon fiber, and it goes back to the lightning strike protection on carbon fiber aircraft. As they start to use carbon fiber, they need ways to be able to protect that material on wind blades. So they start using our material. So we're involved in a lot of different industries and a lot of new technologies that are coming out, and we're very excited about it because we enjoy being in the new business and being at the forefront of technology.
You're in a very good position. You have lots of options and lots of markets. Well, I'd like to thank you for joining me on stage today.
Thank you.
I encourage the audience and anyone who's listening to go and visit Decksmet and speak with Ken at booth D78. It's just over by the technical forum in the far corner here. Thank you for joining me on stage today.